Thank you very much. So my name is Lee. I work over at Lawrence Livermore National Lab out in the East Bay here in the Bay Area. I'm a computer engineer there. I work in our high performance computing center, which houses some of the largest supercomputers in the world. This is a picture of Sierra, which is the system in the process of siting now, which is estimated to be about 120, 125 petaflop computer by the time it's installed later this year. I'm also an open source evangelist and run some of the open source work that Lawrence Livermore does internally and in collaboration with the Department of Energy and across the US government as a whole. So recently in the news, there have been a lot of data breaches. There have been a lot of exposures about secrets. Recently there was the Panera Bread. There have been other vendors that have recently been hit and have had some secrets, had some leaks, had some information get out the door. And so how do these things happen? Well, back during World War II, there was this comic, don't discuss your secrets on the telephone. Perhaps now it's time for an updating. We could say, don't discuss your secrets on the internet instead. And the reality is, though, that we're actually putting more and more of our secrets out there. So with the prevalence of code hosting tools like GitHub, GitLab, Bitbucket.org, Bitbucket services in general, as well as other cloud hosting services like Amazon Web, Google Cloud, and Microsoft Azure, we're seeing more and more source code and configuration move out of the internal environment and into external environments. And sometimes this can lead to problems. So recently, this is just one particular example where AWS secret keys were leaked as part of a data compromise. So some endpoint was not being properly protected. It allowed access to view the actual source code of some internal application where the secret key was embedded. And there was a talk earlier today talking about how to find some of these in your codes in general and some of the issues with managing keys in mobile applications. So if you just take a look at, for instance, the AWS secret access key and you throw it into GitHub, you'll actually find almost 400,000 instances where this shows up in source code that's out there on the internet today. Now, a lot of times it's benign. It's some sort of placeholder text. There is no actual value there, but that's not always the case. And if you look at the version control history of some of these tools, you don't have to go very many pages through the search results to find things that are actually the access key and secret access key for real production and staging servers on GitHub. Now, one of the issues that we'll talk about in more detail is that Git being a distributed version control system, being something where you're pushing out into the cloud, even when you try and clean up these issues, it doesn't always work quite the way that you expected. So for instance, this particular commit that had this particular file in it had been deleted. It wasn't available on any of the public branches, but it is still being indexed and is still available on github.com because the commit itself hasn't actually been deleted, only the reference to the commit. So instead of hard coding these secrets into your source code, into developer environments, what happens? Well, we end up moving a lot of these access keys and access tokens into our environments. So these are either shell environments or some other environment that we might get through Vault or some other system. And it ends up being that we have code that goes out into the environment, looks and reads the key in kind of dynamically at runtime. And this is great. This is much better than putting the secrets hard-coded into your applications. But how does this play out during a penetration test? So my role at Lawrence Livermore is to actually conduct penetration tests against our HPC systems. And one of the things that is unique about us is we actually invite users in to come and run on our systems. And a lot of the techniques that are developed for single, developers running applications on their laptop or developing an application on their laptop with things like IPython notebooks or Jupyter notebooks and other services like this don't work so well when there's potentially 100 other users running on the same system that you are. So we actually provide this as a service to our customers, so the concerns are a little bit different. So in a penetration test, what will happen? Well, one of the kind of endpoints, or close to the endpoint of a penetration test, is in the post-exploitation, where you've gotten some shell on the system. Again, this is often the starting point for our penetration tests, where if we got on the system, what would we be able to find that we wouldn't want unauthorized users to be able to access? So if you got a shell on a system, you might reach out and try and find out some information about who you are in that system. In this case, I'm just using a Vagrant virtual environment that I created for this talk. So you might find some information about your environment. You might look at the network configuration. You might try and see what kind of privileges you have. So in this case, looking at, do I have any sort of root access? And in this case, you actually do. This user has root privilege without use of a password, which is pretty bad, but that's a vagrant default behavior. And at this point, we can declare victory, right? We're done, we have root on a system, we can write our report, we can move on. Well, if we really want to try and provide more value for either our customers or our users that might be using some platform where we invite them in like this, we actually want to dig a little bit deeper. So let's go back to where our users were setting up these tokens to read things out of the environment. So our environment is a very Linux-heavy environment, and we actually did a lot of the early work on the Linux systems. A lot of the HPC systems that we run were the first ones using Linux as the base operating system back in the 90s. So we actually have a lot of experience with Linux as our operating system. And one of the ways that you might see this come into your environment is through the way of setting environment variables. So here you can see the AWS access key and AWS secret access key. If you're on the host, you can read out your environment with the export command in a bash shell and grep around for some of the tokens. So you might have some in particular that you're looking for that you found through either code or some other means that you want to try and find more information about or more specific keys. But how do the environment variables actually get there in the first place? Well, they can actually get there a number of different ways. One of the ways that they can get there is through the use of shell profiles or environment profiles, where you put the tokens or access keys or whatever into your environment profile, and then this gets read every time you log in. So here, if I was a penetration tester, if I got exploitation of some developer's system, I might be able to read out not just the AWS keys that I was originally sort of privy to and trying to find more information about, but here I can actually find GitLab and GitHub API tokens as well. Another thing that's interesting if you're someone who's compromised the developer system is you can look at the history of what commands that developer has run. If this is someone who uses a shell, often you'll see a lot of history, and you might be able to run some analytics to see what sort of repositories they're talking to, what sort of commands they're used to running, what sort of hosts they're going out to. And a lot of times we'll get on a system as a penetration test, and then we'll try and see what other systems we have access to. And this is actually a nice passive way to find extra systems that may be in scope for a test or some other exercise. So here you can see there's a couple of Git repositories that the users made some effort to. Maybe they're a contributor for these projects. We can look and see what they have in these projects. We also see some pretty obvious glaring bad things, like here they're using MySQL, and they're actually, well, there's a couple of bad things here. One, they're using the password directly on the command line, which means that it's now saved in the shell's history file. So in this case, root is the password, and the fact that it's sort of root as a default login credentials is another bad thing that we want to try and catch from our developers a bit. We might also find other information. Maybe this is a developer that actually does backups of the system, and so we can see things where they're actually dumping out the database information into a backup file. Again, this could give us more information without actually having to move actively through the environment. We don't actually have to connect to a database host in order to find more information about what's in that database. In this case, this is probably just a plain SQL file that we could go read without any encryption at all. So this is all well and good, but once we have some of this information, we want to see what else we could find. Maybe we want to move through the environment, but we want to disguise ourselves to look like what the developer is doing. So in a lot of Linux environments, a common way to move through them is over SSH, the secure shell. And the idea here is that you can connect from your host, so let's say my laptop, onto some other system, and you can execute commands there and do other operations there. So if I was on a developer's system, the first place, if I was looking for secure shell information, is in the home.ssh directory. And there's a couple of things here that you might find that you could leverage pretty quickly and learn a lot about the environment, again, without having to move anywhere off of this one particular box. So one thing that immediately jumps out is here there's a trio of SSH keys, or what are probably SSH keys. And you can see the private key and the public keys with the .pub at the end of them. And additionally, we find the configuration file. So this is a file where developers might put extra information about their environment, hosts that they connect to often, and other things that they might put in as ease of access to some of their hosts. So if we dive into that configuration file, there's a couple of things. This is a fairly simple looking SSH configuration file. And one of the things you can see is there is a host AWS. So here they are defining an alias for an AWS host. And whenever they typed SSH AWS, they'll end up going to that host as EC2-user to a particular host name. This could be some internal IP address or some other host, in this case, in the Amazon EC2 cloud. And in this case, you can see they're using that AWS public-private key pair that we saw in the previous slide. So another thing we can learn is that there's a couple of hosts, DB and web, which pretty self-explanatory what those might be. And here the developer logs in as the root user using a particular production SSH key. So maybe it's a particularly strong SSH key, but they're logging in as that user doing operations there on that host. And for everything else, it's going to fall under this host star section. So any other host that's not one of the three listed above, DB, web, or AWS, is going to use this set of configurations. And here you can see two things, that they're persisting any of the SSH connections they make. So if you connect to that host again, it'll actually reuse the connection from an earlier connection if they have successfully authenticated. And by default, they're going to present that identity file, the ID_RSA, which is the default RSA SSH key format. So coming back to those keys a little bit, if we look at the files, we can actually learn more about the configuration, the strength of those SSH keys. In this case, we can see that the AWS secret key is encrypted, so there's some sort of passphrase that was put on this SSH key. It could be weak, it could be strong. Ideally, we want our developers to use strong passphrases on their SSH keys. But worse than that, we actually see that the default SSH key doesn't have any passphrase encryption at all. So here it's just the actual private key sitting on the host with the public key. If we take those two keys away onto our own attacker's box, then we could actually leverage them in future explorations through the environment. So another file that's kind of interesting in this SSH configuration area is the known hosts file. And it's a little hard to parse. Here is just 3 lines of this file. But a couple of highlights and some more information gathering that we can get from it are any of the hosts that we previously connected to. So here we can see we've connected to the DB and the web hosts showing up here, and then these are the fingerprints of those actual hosts. So these are the public keys for the hosts that we've connected to. And we might find others, again, inside of that environment where this developer has gone out and made connections to other hosts in the environment that we might want to explore and see if we can gain access to, perhaps using that unencrypted SSH key on the previous slide. So another host here that shows up, not unsurprisingly from the bash history earlier, is the github.com URL. So here's actually the host that's responding whenever we do a git clone operation or a git push pull from github.com. And this might allow us, again, in combination with the SSH keys that we see, to actually go out and look and see what else that developer has access to on GitHub. Could be public repositories or private repositories that are able to be accessed with this SSH configuration. So once you're able to access some of these hosts, again, github.com being one of them, maybe some internal servers, what do you want to do? Well, you might want to try and actually find source code and dig deeper into some of these configuration issues that you saw before. So one example, you might look just through the developer's home directory and see what other Git repositories. Here we saw several clues that make us think that this developer uses Git regularly. So we can actually look through for any of the Git repositories that they're using in the system. And we'll see that there's a couple here, the CPython and the Django repositories that we would expect from our earlier look at the history file. But we can also see there's this other special project directory that we didn't see in the history before. And there's a number of reasons why that could be. But if we actually look into it, perhaps we find some more information. Maybe we find some source code that's either valuable in and of its own self. Maybe we're trying to actually prove that we can get to some development source code as the purpose of our penetration test. And if we actually look at that source code, maybe we'll actually find some more secrets or some more information about hosts that it's going out connecting to and that we might be able to leverage further in our attacking. Again, if we look at this configuration, we didn't see it as part of the bash history, but perhaps we could actually look at the Git configuration for such a repository sitting on a file system and find more information, again, about what servers this developer has access to and where they might put their source code. So in this case, the repository in question, this special project, Git repository is actually hosted on, in this case, an internal gitlab.example.com server. So maybe this is inside of the actual intranet rather than out on the public internet on github.com. So that gives us our SSH. We've gotten some source code now. But one of the main points of exploitation and post-exploitation is actually developing persistence. So here, this isn't actually just something that attackers want to do. In fact, we actually have developers that want persistence into various environments as well. And one of the ways that we see developers do this is through a built-in command or a fairly low-level, fairly available command called screen. So screen allows you to start a shell session that will persist after you disconnect from the host. So imagine I'm a developer, I'm working on something from the road, I want to be able to get into a server, and then when I have to get off the train, I want to be able to close my laptop and move on, but I want some long-running process on some remote server to continue running in the background, continue running on that host. So I might start a screen session. Here perhaps we might find one if we're listing out screen sessions that are already available. We might find one, in this case, labeled db maint, so that maybe gives us some hints as to what that screen session might be about. And we can try and reconnect to that using the -r command, and we'll end up in some sort of screen session. Now, typically this is the screen running on the host where you're executing the command. However, it's possible that what you find inside of this is actually a connection out to some other host. So potentially, if I'm a developer working on my laptop, I need to go to some gateway system, but the code I really wanted to run was on some deeper on the inside internal server. So here I've opened up a screen session on the gateway server, and then I'm actually connecting from that deeper into the network, here into the database server. And you can see, again, going back to that SSH config, we're actually landing on this system as the root user. So there's several bad things here that we can point out pretty quickly. But we can also learn some more about what this developer has been doing on this system. Again, seeing what commands they've actually been executing. Here we'll actually see some history of whatever they've been doing. In this case, seeing not just the command, but also the warnings that they got about how they shouldn't have put their password on the command line in the first place. So we can get out of this screen session and move on to see what else is in this environment that we could take advantage of. But before we leave, maybe we want to start our own screen session and make some sort of persistent connection out to our own command and control server. So here we can actually leverage the developers' tools themselves to create some persistent connection out to a system that we control as the attacker doing the penetration test. And we can disconnect from that screen session, and unless the developer actually looks at that system, they may not notice that that session is actually still sitting there, still running in the background. But if you do the listing of the screens, you'll actually see that it is still sitting there and able to be reconnected to in the future. Again, running our reverse connection out in the back. So just as a recap, we have here several user environments user environment features that we can actually leverage as part of a penetration test. We have things like shell environments, profiles, and the history of those commands to actually see what's going on inside of a developer's system. This will allow us to passively gain more information about that environment. And what's important to note here is that it may not just be that one developer, but similar developers inside of the organization may have similar approaches to doing things. And so as we get from one developer machine to another or between different servers, we can actually learn more about what's going on in that environment. SSH here, configurations, we can find some key pairs that we might be able to leverage. There's other things that we could dive deeper into, like the persistent connections and how we could actually reuse any of those persistent connections inside of the environment to move laterally once we've gained access to this one host. But we can also use it just to find other hosts that might be of interest. If we have these other systems that we know are doing, or we suspect at least are doing some sort of database operations or web server operations, those might be our targets depending on the scope of our penetration test. Obviously, developer source code is very important. We can find some internal repositories, external repositories, and you might be surprised at what sort of code you find in those histories. Again, when we saw the example earlier where a commit got pushed to GitHub but not properly cleaned up, we can see the same thing sitting on a developer system. If some secret got committed into the Git repository, let's say the developer caught it in advance of pushing it outside of the corporate firewall onto some external server, they might not have done the same level of rigor to clean it up on their internal server. So if you're on that developer's system, you might actually be able to look through other parts of the Git history to see and find other credentials and password and information in these dangling commits that are not being referenced anymore. And again, persistence is always important, and it's not just something that attackers worry about. Developers actually have come up with these tools that we can reuse and live off the land to incorporate into our penetration tests. So I don't want to cast a bunch of gloom on developers. I myself came from a development background before moving into the cybersecurity side of things, and I use these techniques myself in my day-to-day operations. But it's important to know what the limits of them are. So for instance, using SSH keys without any sort of passphrase is just generally not a great idea. It solves the I don't want to have to type my password problem, but again, that's really working around your issue. A lot of the code hosting tools will actually allow you to disable using SSH keys if you wanted to, if you make that decision, but they can provide value. If you do decide to leave it on, it's important to train your developers and show them that how to use passphrases, how to do things more securely. For instance, it may be that you want to advise your developers not to put key pairs everywhere on every system that they're using, but instead manage them on one system where they have tighter control over what those keys have access to and how they're actually used and made available to other systems. So knowing what's in your history is obviously an important thing. One of the takeaways that we had recently was actually to start monitoring our service account histories. So if you have some service account that's running, let's say, a web server, you might want to actually monitor what that service account is doing as part of its operations. If it's getting a lot of shell history, if it's getting a lot of command execution, that might be a sign that it's not just the normal maintenance that you're used to experiencing or that your developer are doing, but instead that someone has gotten onto that system and taken advantage of some vulnerability in some application and is executing commands. So this is a way to find what's actually being done. And I'll close out here by saying, there's many good static code analysis tools that go along with this. So if you're looking at your source code for your corporate internal repositories, it's good to incorporate tools. Here I put out just a couple of links for the OWASP has a list of tools by language for what to use. Myself personally, I'm mainly a Python developer, so I put Bandit here as one of the tools that I incorporate into my workflow. But I think one of the takeaways that I want to emphasize is that just having static code analysis isn't enough even in and of itself, and instead you actually want to have version control aware code analysis. So there's a couple of tools. One's out by 18F, which is a sub-agency of the General Services Administration in DC, and AWS Labs both have tools that will go through your Git history, looking at all of the commits in your repositories for these same sorts of issues. So it's not just I have look for the use of password equals thing in my continuous integration tests, but actually go through the history. This is particularly important if you're moving from having code hosted internally to code hosted externally. Before you push your code out there, you want to make sure that everything in the history is also good, and it's not just good today. Sometimes you can find secrets like this in your source code. Depending on what kinds of things they are, you might actually decide that instead of actually pushing an entire Git repository out from inside our firewall to outside our firewall, what we instead want to do is actually trim off just the top commit, make a new Git repository that's brand new, we've checked out, and there's nothing in the history. So there's a couple of concerns to trade off there. And at that point, I'll take any questions.